Welcome. Have you ever wondered how your smartphone is made or how gasoline is refined from crude oil? The answer lies in a fascinating field known as process technology. In simple terms, process technology is the science of transforming raw materials into valuable products. It's the magic behind turning basic ingredients into the things we use every day. This essay will guide you through the fundamentals of process technology, explaining why it's an essential area of study, especially for aspiring scientists and technicians like you. We'll explore the core principles, highlight its significance across various industries, and provide clear examples to solidify your understanding. Get ready to embark on a journey into the world of process technology. It's more than just science, it's the engine that drives innovation and shapes our modern world. Why is process technology so important for students in science and technology? Imagine a world without the knowledge and skills to transform raw materials into usable products. We wouldn't have medicines, fuels, clean water, or even the materials to build houses. Process technology is the backbone of countless industries, making it a field brimming with diverse and rewarding career opportunities. As a student of science, mastering the principles of process technology opens doors to a wide range of professions. You could become a process technician, a chemical engineer, a quality control specialist, or even a researcher, developing new and sustainable processes. The demand for skilled professionals in process technology is constantly growing, making it a secure and future-proof career path. By understanding how processes work, you gain the power to innovate, solve real-world problems, and contribute to advancements that benefit society. Before diving into the complexities of process technology, let's first understand what we mean by a process. In our everyday lives, a process is simply a series of actions or steps taken to achieve a particular outcome. Think about baking a cake. You follow a recipe, combining ingredients in a specific order, applying heat for a precise duration, and finally ending up with a delicious treat. In a technical context, the definition of a process remains similar but becomes more specific. A process is a series of operations that cause physical or chemical changes to materials. These operations can involve heating, cooling, mixing, separating, or reacting substances to create a desired product or achieve a specific goal. Whether it's baking a cake, building a car, or even sending a rocket to space, every complex task can be broken down into a series of defined processes. Understanding this concept is fundamental to grasping the essence of process technology. We've explored the concept of a process. Now let's add technology to the equation. In its simplest form, technology refers to the practical application of scientific knowledge to create tools, techniques, and systems that solve problems or improve human life. When we combine process and technology, we get process technology. This field focuses on designing, operating, and optimizing processes that transform raw materials into desired products efficiently and sustainably. It's about applying scientific principles and engineering ingenuity to make production processes safer, more efficient, and environmentally friendly. Process technology is all about using our understanding of chemistry, physics, biology, and engineering to manipulate materials and create things that improve our lives. It's the bridge between scientific knowledge and real-world applications. Section 5, Powering the World Industries Driven by Process Technology. Process technology is the invisible force behind countless industries that shape our world. Let's look at some key sectors where its role is absolutely crucial. 1. Oil and gas. This industry relies heavily on process technology to extract crude oil and natural gas, then refine them into fuels, lubricants, and other valuable products. 2. Chemical manufacturing. From plastics and fertilizers to pharmaceuticals and cosmetics, the chemical industry uses process technology to synthesize a vast array of essential products. 3. Food and beverage. Process technology is essential for preserving, processing, and packaging the food we consume, ensuring safety and extending shelf life. 4. Pharmaceuticals. The production of life-saving medicines involves intricate processes to synthesize, purify, and formulate drugs that meet stringent quality standards. 5. Water treatment. Process technology plays a vital role in purifying water for drinking, sanitation, and industrial use, making it safe and readily available. These examples merely scratch the surface. Process technology is ubiquitous, impacting virtually every aspect of our modern lives. Let's make process technology more relatable by looking at some everyday products and the processes behind them. First, we have gasoline. Crude oil, a complex mixture of hydrocarbons, undergoes fractional distillation. This process separates it into different components based on their boiling points, yielding gasoline, diesel, kerosene, and other fuels. Next, let's talk about plastic bottles. Polyethylene terephthalate, or PT, is produced through a polymerization process that links small ethylene glycol and terephthalic acid molecules into long chains. Chocolate, a favorite for many, goes through quite a journey. From cocoa bean to chocolate bar, the process involves fermentation, drying, roasting, grinding, conching, tempering, and molding. Medicines, on the other hand, have active ingredients that are often synthesized through multi-step chemical reactions. These ingredients are purified to remove impurities and then formulated into tablets, capsules, or liquids. Lastly, there's paper. Wood chips are pulped, chemically treated, bleached, and then pressed and dried to create the paper we use daily. These examples demonstrate how process technology silently works behind the scenes to provide us with the necessities and luxuries of modern life. Within the realm of process technology, we encounter two main types of processes, chemical and biological. While they share the goal of transforming materials, they achieve it through different mechanisms. Chemical processes involve chemical reactions, where molecules interact and rearrange their atoms to create new substances. Think of rusting iron, burning wood, or baking a cake, all driven by chemical reactions. Biological processes, on the other hand, utilize living organisms or their components, like enzymes, to facilitate transformations. Examples include fermentation, using yeast to make bread or beer, wastewater treatment using bacteria to break down pollutants, and even the production of some pharmaceuticals using genetically modified organisms. Often, these two types of processes work in tandem. For instance, in biofuel production, plant materials are first broken down by enzymes, a biological process, and then chemical processes are applied to convert the resulting sugars into ethanol or biodiesel. As we've discovered, process technology is the driving force behind the creation of countless products essential to our daily lives. It's a field that beautifully blends scientific principles with engineering ingenuity to transform raw materials into valuable commodities. We've learned that a process is a series of steps that cause physical or chemical changes, and process technology is the application of technology to design, operate, and optimize these processes for efficiency and sustainability. We've also explored the crucial role process technology plays in various industries, from oil and gas to pharmaceuticals and food production. Additionally, we've differentiated between chemical and biological processes, highlighting their unique mechanisms and applications. Understanding these fundamental concepts provides a solid foundation for further exploration of this fascinating field. As you delve deeper into the world of process technology, you'll encounter two crucial terms: unit operations and unit processes. Unit operations are the basic building blocks of any process. They are individual physical operations like mixing, heating, cooling, filtration, distillation, and drying. These operations are common to many different processes, regardless of the specific materials being processed. Unit processes, on the other hand, involve chemical or biological transformations. Examples include oxidation, reduction, hydrogenation, polymerization, and fermentation. These processes are specific to the materials involved and the desired chemical changes. By understanding and mastering these individual unit operations and unit processes, engineers and scientists can design, control, and optimize complex processes to produce a wide range of products efficiently and sustainably. This modular approach forms the backbone of process engineering and is essential for tackling the challenges of producing everything from fuels and plastics to medicines and food. Your journey into the world of process technology has just begun.